Let's work through this exam paper. We're looking at 2021 FP1 question number 1. All right, so we have an equation f of x equals x cubed plus 4x minus 6. Show that the equation fx equals 0 has a root in the interval. So all we need to do is substitute the ends of the interval and show that there's a sign change. Remember, you don't need to find the value, you just need to show there's a sign change. So f of 1, that's going to be 1 plus 4 minus 6, so that's negative. And then f of 1.5, guys, can we get 1.5 calculated, please? $3.375, which is positive. So therefore, given that this is a continuous equation, there are no values for which there is no solution, there must be a sign change. Okay, part B. Taking 1.5 as the first approximation, apply the Newton-Raphson process twice. Do you remember the formula for Newton-Raphson?
Yeah.
Go on then.
X minus f of x over f dash x.
X minus f of x over f dash x. So what you're actually saying is xn equals xn minus 1. Yeah? So each term is the previous term minus those two. Now we've given our first value of 1.5. So let's make a bit of space here. So x1 is 1.5. So x2 is x1, 1.5, minus f of 1.5 over f dash 1.5. So in order to do that, we really need to find out what f dash x is. So going back to the original equation, it was x cubed plus 4x minus 6. So f of x is x cubed plus 4x minus 6. So f dash x will be 3x squared plus 4. Is everyone okay with that? So we're putting our values in. Can we get a calculator, please? Well, we already know that f of 1.5 because we found it here. So 3.375. Don't repeat your work. Is it 10.75, is it, for the denominator? Is it 10.75 for the denominator?
Yes, it is. Something like that, yeah.
Okay, so what does that give us for x2?
1.186.
1.186. Does that seem reasonable?
Yeah.
Remember, we're looking for a solution between 1 and 1.5, and our value is within that range. So that's an acceptable kind of solution. We need to do the process twice, as it says in the question. One more time. Yep. So x3 will be 1.186 minus f of 1.186 over f dash 1.186. Put those fingers on those calculators. What do we get? Oh, bless you. What do we get?
1.13589.
1.135. 89, etc. What kind of accuracy are they looking for? 3 decimal places. So 1.136 to 3 dp. Okay. Part 2. Does g of x, so this is an unrelated question. G of x is 4x squared plus x minus tan x, where x is measured in radians. The equation g of x equals 0 has a single root in the interval. Use linear interpolation on the values of the endpoints of the interval to obtain an approximation of beta. Okay, so you remember we're trying to find this point. Our value here is 1.4. And our value here is 1.5. So we need to find f of 1.4 and f of 1.5. Obviously it might not be negative or positive, but find those values out. And so f of 1.5 divided by 1.5 minus x equals f of 1.4 divided by x minus 1.4. Yeah?
For the 1.4 is 3.44.
The f of 1.4, yeah?
F of 1.4 3.44, and for 5 is minus 3.6.
Right, do we need those right now? Is this a good time to substitute?
No, so you can just put them as variables like D, or...
Right, so, I mean, the best thing to, well, you can leave them as f of whatever, but really it would be more effective to rearrange for x first. Yeah? So you get x minus 1.4 times, okay, let's call this b and let's call this d simply because you wanted those letters. So that's b equals d times 1.5 minus x. Multiplying out, you get bx minus 1.4b equals 1.5d minus xd. So bx plus xd equals 1.5d plus 1.4b. So therefore x is 1.5d plus 1.4b over b plus d. Also, can I remind you that you have the store functions on your calculators? So the best way of doing this is to take those two answers that you calculated, f of 1.5 and f of 1.4, store them in letters b and d, and then just type in the final value, and that way you don't lose any accuracy marks. Yep.
So what I would do, I'm not sure if that would get the marks. At this stage, I just store the variables b and d, and I just head right over to the equation part of the calculator and plug that entire equation in and solve for f.
So you're saying whether using the calculator to work it out, would it get you full marks? Is that your question?
I do have this written down, but I don't have these written down.
Well, funnily enough, here's the mark scheme. So for the mark scheme, you need to calculate 1.4, 1.5, which is fine. And then you've got your statement. It says it wants this or this as a statement. The correct linear interpolation statement as shown may omit the zeros. Other forms are possible. Now, this is a B1. A B1 saying it must be stated and only a correct answer. There's no method marks for this. So as long as you write down this, you get the B1 mark.
Okay, so that's good.
Yeah. And then the next stage is just asking for the answer.
You get 2 marks.
A1, and you get a method mark because clearly you've used some method. And if that method is the calculator, that's acceptable.
Oh, okay. Wonderful. Okay, that's fine.
Do we get the correct answer? 1.448869? Yep. Wonderful. And the accuracy requested was 3 decimal places, so it would be 1.449. Okay, let's move on. Question number 2. The complex numbers Z1, Z2, and Z3 are given by blah, where P is a real number, so we have a variable in there. Find Z2 times Z3 divided by Z1 in the form A plus BI. So here they are clearly separate into real and imaginary. And give your answer in its simplest form in terms of P. Okay, cool. So first Z2, Z3 is going to be P minus I. Ooh. I think it's a typo.
It's a typo. Yeah,
It's a typo.
Yeah, we've done this question.
Yes,
before.
put it in class.
Yeah.
All right. So P minus I times P plus I will be P squared plus 1, because it's minus I squared, so it's minus 1. P squared plus 1, and that's it, right? Because it's minus PI plus PI. So P squared plus 1. Lovely. And then we're going to divide that by Z1.
2 minus I.
How do we do that?
And now we do the conjugate thing again.
Yeah, we multiply top and bottom by
2 plus I.
2 plus I. Very good. So multiplying the top, we get 2p squared plus 2.
Is that plus 1 or I? That should be plus 1, right?
This is 1. This is a 1.
P squared plus 1?
Plus 1, yeah.
Okay.
Because it's minus pi plus pi, so the i's terms will cancel. So 2 times that is that, 2p squared plus 2, and I times that, well, we'll just keep it separate. I times p squared plus 1, yeah? We don't need to multiply it out, that's just pointless. And our denominator, again, middle terms will cancel out, so it's just first and last. First is 4, last is
So you should give it a second.
1. So 4 plus 1 is 5. Okay, and now we can separate into 2p squared plus 2 over 5 plus p squared plus 1 over 5i. 3 marks in the back. Now this is equal to 2 root 5. Part B.
Aren't you meant to do the magnitude? Yeah, you're not meant to do the magnitude first.
No, well, in part A.
Part B.
I haven't started.
You said that equals to 2 root 5.
Yeah, no, I haven't started yet. Calm down.
No,
Right.
you literally just said.
Hang on.
Hang on.
Yeah, hang on.
Alright.
All right.
Yeah, I'm hanging
Look,
on.
this. Yeah, I know you're hanging on my every word, but so this is 2 root 2 plus 5, and this is p squared plus 1 over 5, right? And we want to find that. So it's just Pythagoras, right?
Yeah.
Okay. So p 2p squared plus 2 over 5 squared plus p squared plus 1 over 5 squared equals, what's the square of that?
20.
He said there's this wonderful thing on the calculator called equation mode.
Oh, you and your occasion mode. But then when one day you won't be able to use it, you'll be like, no, I've forgotten how to do this.
Nah, I just do it physically, but like, why would I not just say time and just type that onto the calculator?
All right, so that's going to give us 4p to the 4 plus 2 times that, that's going to be 4 plus 8p squared plus 4. Our second brackets are going to multiply out to give p 4 plus 2p squared plus 1. And all of that is equal to 5 squared times 20, so 20 times 25.
So he's like 2.
500. So you get 5p to the 4 plus 10p squared, and that's minus 495. And we can divide by 5. So we will say, let's say p squared equals a, so that's going to give you a squared plus 2a minus, how many 5s in that? That's going to be 199.
Yeah.
So what numbers are that?
We can't see the board, so we just.
I think it's like 5, yeah.
No, so it's 90.
Huh?
You guys call that random numbers?
What did you get?
99
I
no?
thought you said 100.
So what did you get for a?
5.
Is that right? Have I got it wrong?
I have no clue.
11 and 9.
Yeah, you get like 9 and minus 11. The word is so delayed.
Okay, cool. So yeah, so we get a is clearly 9 and 11, right? Don't say it. And the 11 is the positive one, and the 9 is the negative. So therefore, a equals 9, or a equals minus 11. However, we said p squared, so p squared is 9, or p squared is minus 11, which is rejected. So p equals, so is it plus and minus 3? Would both be acceptable?
Why are you rejecting minus 11?
Because it's that p would be, what's the square root of minus 11?
Why are you rejecting minus 11i?
11i, right. But what does the question say?
Why are you square rooting minus 11?
What does the question say?
Possible values.
P is a real number, not a complex number.
Oh, that's crazy.
You thought you were being clever there, right? You were like, we can square root negative numbers now.
No, I was confused with that. But it says possible values.
Yeah, so just plus or minus.
So that's the plus or minus, that's right. Yeah, and absolutely do that. When you read the question, when you see values, underline it.
Yeah.
Yeah? Remember that is just their way of giving you tips.
Yeah. Here's the funny thing, sir.
What's the funny thing?
So like,
Negative 11 is actually the answer.
What?
so like, I just directly typed in the 20 equals something something squared,
Mhm.
something something squared, and I got my answer.
And is it the same answer?
It's the same answer.
So what was funny about that?
The fact that
You need to redefine your humor centers.
No, because on the actual exam, I wouldn't be going through the process that takes way more time. Though.
Well, look at the mark scheme.
Okay.
Let's look at the mark scheme and
Okay,
the board.
Yep, I'm right. Jumping right here, straight to the answer. You get the marks. That's crazy too.
So here,
Good point. It's almost like
What? It's like you want to learn stuff, man.
Huh?
Learn? I'm not learning anything new.
Huh?
Okay, a triangle has vertices 2, 1, 2, 3, and 0, 1. Triangle T dash is the image of T under the transformation represented P. Find the coordinates of the vertices of T dash.
X becomes Y, and then Y becomes negative X. You know?
It's great, isn't it, when you can look at it and you understand it rather than you have to do it.
What?
Oh, this is a 2 by 3. and a
No,
2 by 2.
what?
Yeah.
Oh, you
that's the
mean
matrix of the
that
triangle.
way.
Yeah, that's the matrix of the triangle.
Bro, but that's like such a weird way of doing it.
No,
No?
no way of doing it, bro. If you plug that into your
No,
calculator.
like straight up, you just like I'd say like, you know, this becomes Y, the X becomes Y, and the Y becomes negative X. So this one becomes 1, and this becomes negative 2. This one becomes 3, and this becomes negative 2. This one becomes 1 and 0. Done.
Sure. Yeah. So I literally just did that, but is that okay?
Yeah, but no, I'm saying that looks weird.
Cool. Well, that's the proper way of doing it, so anyway.
That's crazy.
Describe fully the transformation represented by P. So think about what's happening here.
Draw it.
Well, you don't need to draw it. You just need to understand what's happening.
Call it like rotation.
Your X is going to become, so let's say 2, 1 is here. And 2, 1 is going to become 1 minus 2.
Yeah, I agree.
Yeah, 2, 3 becomes 3 minus 2.
Yeah.
So this line becomes this line. So
Yeah,
it's
that
a rotation, 90 degrees
Rotation.
clockwise.
I was right. Yeah, I do agree.
90 degrees. Remember, you need to say all of these three things to get the points.
Yeah. All of those, yeah, okay.
You're
There you
about to bust out laughing. I can tell from your voice.
The 2x2 matrix Q represents a reflection in the x-axis.
Wait, let's just see what you did. You didn't say anything.
You can't see anything.
Rotation. So you drew it,
Yeah.
and then you drew the second part of it, and you're like, rotation by 90 degrees.
Yeah, because this line.
It's always in the origin. It is, right? When it comes to
Yeah,
matrices.
they don't
These ones are origin. Not all of them are, but that comes later.
But they don't give us anything without origin.
Yeah,
Why
at
is
this
it
stage.
square?
Hey,
Why'd you draw a square?
I was just drawing a sample shape.
Yeah,
It's a triangle.
it's this side.
It doesn't matter.
It's just this line, bro. Just draw this one line and you bend it. How does it bend? That's crazy, bro. It looks like 90 degrees bend to me. I know, right? It's crazy. Unfathomable.
Okay, the 2x2 matrix Q represents a reflection in the x-axis. So a reflection in the x-axis would turn AB into A minus B. So you can deduce that that is unchanging the values,
Oh, one,
but changing the,
and 0, -1.
yeah, but changing the y coordinates.
Oh, okay. Next one, the anti-clockwise by 90 degrees. Right, we check our booklet. We see how to rotate it 90 degrees, and we put that in as a matrix.
Yeah. Wait, is it 12 or anti-clockwise?
Well, think about this. This turns, let's say, 2 minus 3 into
Is it possible that
3, 2. So how are we changing that? Are they switching position?
Say that again? Why is it 2 minus 3, 3? I can't see them.
It's below the delay.
2 minus 3, 3, 2. Okay.
So 90 degrees anticlockwise would turn 2 minus 3, which is here, into 3, 2, which is here.
How do you know that?
Wait, the x coordinates become the y coordinates. The y coordinates become the x coordinates.
But there's also a negative sign change, right? So because the coordinates change, you know it's a 0, 1 rather than a 1, 0. Now you need to know that the x becomes y, but the negative y. So therefore this is a negative 1.
Can't wait to see it.
Oh no, wrong way around.
Sir, can you divide matrices?
Hey?
Can you divide matrices?
Oh, no.
No, you multiply by the inverse matrix.
Loser.
This God is talking.
Determine all of this.
All right, so what turns 2 minus 3 into 3, 2?
You did it wrong, little bro.
What's it going to be?
You did it wrong, little bro.
So 0 times 2 is 0, but this is going to turn into 3, so therefore the minus is on top. Find the matrix RQ, so that's 0 minus 1, 1, 0, multiplied by 1, 0, 0, minus 1. Can't believe this is further maths, huh? 0, 1.
You know, it'd be really nice. Like,
1, 0.
see the working out.
I know, it'd be crazy. If only.
Hey, stop criticizing my slow board. Yeah, everyone.
Someone needs some fixing, sir. Needs some rebooting. Computer science should be able to do that.
Yeah, man, right?
Mm, should be able to. Okay, so what does a new matrix 0, 1, 1, 0, what does it do?
Not 7 either. 2.
What-
Full description. Can we see the
I'm telling you, 0, 1, 1, 0, what does it do?
0, 1.
It becomes a reflection on like y, x, y.
Very good.
Y equals x.
Yeah.
Y equals x. And it's almost like I can draw the graph in my head.
What, on your forehead?
Yeah.
Yeah.
Exactly.
That's it. Hey, it's not circular geometry, you know.
Hey, it could be.
It's very cool. The rectangular hyperbola
Perspective, you know.
has equation xy is 25. The point 5t, 5 over t, where t is not 0, is a general point on h. Show that the equation of the tangent to h at p is that. All right, so how do we do that?
The gradient.
How do you find the gradient?
Y equals 25 formula.
Use y equals 25 over x, you differentiate.
Yeah,
What-
then you differentiate.
Yes.
So y equals 25x to the minus 1. So dy by dx is minus 25
Over x squared.
over x squared. And x you know is 5t, so minus 1 over t squared. Okay? So y equals mx plus c. So y equals minus 1 over t squared
No, so it's the tangent.
x. Huh?
The tangent.
Oh, so it's just t squared. Very good. Yeah, sorry, it's tangent. So minus 1 over that will just give you t squared. So y...
What?
It's the negative reciprocal because the tangent.
Tangent.
Yeah, it's not
Yeah,
normal.
yeah.
It's not the normal.
Yeah, tangent. Not
No, it isn't the negative reciprocal. It's a tangent. It's not the normal. It's just a gradient. I don't know why you just confuse me like that. Honestly, confusing me like that, Sammy.
Gotta keep you on your toes, sir.
He's just, he was testing you, sorry.
Yeah.
He was testing you. See if you know yourself before teaching us. It was
Okay, so that's what we have so far. So how do we solve? We need to find c, right?
Yeah.
But we know that the point P is on that line.
Okay.
So we can plug x equals 5t and y equals 5 over t.
Yeah.
So 5 over t is minus 5t squared over t squared. Is that right?
Yeah.
No, 5t over t squared.
Close enough. It's actually t cubed though.
No, it's not.
What?
What are you talking about?
Oh no.
We're putting 5 over...
T was y, yeah.
Yeah, 5t comma 5 over t, yeah? So that's why, that's that. E plus c. I know, I just hadn't got around to writing it. So c equals 5 over t
Plus. Sorry,
plus 5 over...
So that's 5 over 5.
5 over t plus 5 over t, which is...
5 over t, yeah.
Go on.
That's like 10 over t. That's 10 over t.
10 over t. Well done, you can add fractions.
Thank you, sir.
You're amazing. Right, and plugging that back in here
Yeah, and then
gives you
multiply
y
everything by t.
equals minus x over t squared plus
Minus 1
10 over t, and then multiply everything by t squared. You know, since this is being recorded, everyone is learning how annoying you are.
That's fine.
Multiply everything.
Everybody knows.
And this is also true. Multiplying by t squared gives you t squared y plus x equals 10t. Is that the format that they require? Yep.
What? Oh, that's so weird.
Okay, cool.
Oh, it's because you don't. Okay.
All right, so that's 4 marks in the bag. The distinct points Q and R lie on H. The tangent to H at point Q and the tangent to H at point R meet at 15 minus 5. Find the coordinates of P of a Q and R. The distinct points Q and R lie on H. The tangent to H at the point Q.
Do we have a point Q or point R?
So there are 2 points on H. So we have our hyperbola and we have 2 points on H. And the tangents at Q and the tangent are meet at point. So the tangent here,
Don't they both have the same formula from A then?
and the tangents meet at the point 15, 5, 15 minus 5. So this is what the question is saying. All right?
No, we can't see. What happened?
Right.
Oh,
So,
it's 2 tangent. Okay, yeah.
yeah. So we know the general formula of the tangent.
Yeah.
The general formula of the tangent is t squared y plus x equals 10t. So we know what it is for different values. Now we know that it's going to go, that tangent will go through the point 15 minus 5. Yeah? So therefore there are two values of t where that tangent will go through 15 minus 5.
That's fine.
Yeah? So we're putting 15 minus 5 in here. So minus 5t squared plus 15 equals 10t. So therefore, put everything on the right hand side. You get 5t squared plus 10t minus 15 divided by 5. So t equals, so it's going to be 3 and 1, and it's going to be plus and minus. So t equals 1 or minus 3. Yeah. So we know that the general point is 5t 5 over t, right?
From 5 and
So 5 or
negative 15 and negative 5 over 3.
easy peasy, right? Yeah. But that first part is the hardest part, visualizing what the question actually means. Once you've done that, then pretty straightforward. Okay, let's move on.
What question was this?
4.
4. How many questions? 7? 8? 10?
8 questions. So
Wait, so that was question 4?
yeah.
Oh, yeah, we did 4 questions.
Cool. Find the rule. D is a positive constant. Find the 4 roots.
Cool, bye, bye.
That is so wonderful, sir. Oh,
Find the 4 roots of f of x, giving you answers in terms of D. So how do we do that?
So we factorize the first part of it with the 9x squared plus b, because they have to both have 3x, so it'll be 3x plus.
How do you know?
No, would you just equate it to 0 and then just solve it out?
yeah, that's what I was thinking. Equate it to 0, because that's what the roots are.
And then because the next part gives you d, then you can just write it in I form also, right?
What?
So you do 9x squared
If
plus
you
d is equal
equate
to
it to
0.
0, yeah, of course you have to equate it to 0.
No,
but
that's
then
how you
after
get the
that,
No, but then it's giving you d is equal to 4, right? For the next part.
no, that's the next one. You can't use that. It says giving your answer in terms of d.
Yeah,
You
but
can't just use d
no, no,
equals
that's
4.
not, that's
No.
not what I'm saying. What we're saying is if you equate to 0, you can find 4 different values
Yes,
for roots.
we already know
And
that.
the next question, when they give you what d is, you can just submit those values, the value for d, to find the actual, literal, complex number
Correct.
of the roots.
But that's not the part that we're confused about. We're on part A, where you meant to factorize it, and you're meant to find the factorization in terms of d.
So you know, so you just write as x plus equal to minus 3 over 9 and x equal to root minus 3 over 9.
No, but then he says, how would you know what the coefficient of x is in any of the roots?
I'm finish your discussion and I'll explain how to do it.
Search easy one.
You know, I don't mind. It's good discussion. Right, so given that you're looking for roots, you want to find out when this is 0, right? So that's either when this is 0 or when this is 0. So when is this 0? When x squared is minus d over 9.
Yeah.
Or x1 is square root of minus d of root minus d over 3. X2 is negative root of minus d over 3. Obviously d is probably a negative number, otherwise that gets a bit messy. And then how to find this? Well, use your quadratics, right? So a is 1, b is minus 8, and c is 10d plus 1. So the square root, so the solutions are for x3 and x4 are negative b plus or minus square root of b squared minus 4a times 10d plus 1
Was the discriminant that plus 4ac?
b squared minus 4ac, all divided by 2a. So that's going to be 8 divided by 2, which is 4, plus or minus square root of, what do we have?
Discriminant was plus 4.
So it's 64, so it's going to be 60 minus 40d, all divided by 2. But you can change that 2 into root 4, and then simplify it further, and get 4 plus or minus square root of 15 minus 10d. Is everyone okay with what I've done there?
Yeah, question. Is there a way to do this without having to use the quadratic formula? Because if it's a 3-mark question,
You could use completing the square.
Do you really want to complete the square?
You're not going to get lots of marks for doing GCSE level maths.
that's not fair though, because it still takes time.
Oh no.
What are you going to do about it? Cry?
Yeah.
If only there was a... No, it's fine. So you've got that, that's x3 and x4. And now you're told,
That's wonderful. Go ahead and plug in that equation.
given d equals 4,
Yeah, we should include both variables x and g in your calculus. That's
so d equals 4, so d isn't negative. That's annoying. What does that tell you about these? Imaginary, right? So square root of 4 is 2. So that's going to be minus 2 over 3i plus 2 over 3i minus 2 over 3i. Okay? And then we have d is 4, so that's 4 times 10 is 40. 15 minus 40 is minus 25. So that's going to be 4 plus or minus 5i. And then it says, show these 4 roots on an Argand diagram. So plus 2 over 3i, minus 2 over 3i, 4 plus 5i, and 4 minus 5i.
Yeah.
It's beautiful.
Yeah, you see that diagram? There,
Yeah.
as if by magic.
Yeah, I see many dots. Wonderful.
You okay with that, Marvelous?
So aren't you supposed to label them?
No?
Why?
Are you not?
No, would you draw those arrows? In the marketing, they ask you to draw those arrows.
Yeah.
You just draw the arrows to the
Yeah.
center. You didn't have to label them.
Yeah, exactly.
Yeah, those arrows.
We do draw. In the marketing, they generally award you
Yeah,
marks for the
they
arrows.
use more for the arrows. Sir?
Mm-hmm.
For this question.
As requested.
See? They do write the point. Yeah.
You don't have to, bro.
Yeah.
Sir, can you scroll up real quick? The mark sheet for part B. I want to see if they use the quadratic formula. Maybe they use a different method. They use the quadratic formula. These. Alright. Thank you.
I also did completing the square.
Where?
Below. It says or. Part A.
Oh, let me see.
Yeah,
Or
yeah, you have 2 roots. Sammy didn't do anything. He just read it. Come on, let's not praise mediocrity now.
oof.
Hey, so it was very tough to read that Morse code.
With the word freezing everything.
Well, you with GCSE English, it's the least I can expect.
Actually, what do you get in GCSE English? Real quick.
Which one?
Language.
7.
So there were 2 levels of words you couldn't read. Is that what you're trying to say?
Literature.
So Marvelous couldn't read or.
Literature.
Sure, you
6.
couldn't read the word.
6.
You couldn't read the word.
I didn't even know where to look.
You couldn't
I was like, where?
See, you can't even read.
I'm dying.
Well, you know, if you would wear your glasses, you'd be fine.
Yeah, see that distance? That's like a whole meter.
That's why you would have to sit 1 meter from the screen. The parabola C has, truth bombs. The parabola C has Cartesian equation y squared is 8x, and the point 2p squared 4p, and the point 2q squared 4q.
So just do the same thing again.
Show that equation, normals. Yeah, I mean, you guys are okay with this, right?
Yeah, and then write
It's
it
just
down.
messy. It's not hard. It's just lots of linear geometry.
It's interesting that they put 2 of the same sort
Yeah, it is.
Right down an equation. Wait, show that. Wait, go back.
Find the gradient.
Lord.
Equation of a straight line. Yeah, I'll leave it to it. I've gone through the mark scheme, so you'll have a recording and you can have a look at that again. I'm allergic to bad questions.
Sorry, it said part B was like write down an equation for like I think it was like Q, but it was just both of them are the same. So wouldn't they be the same? Here.
No, they're two different points, so the normal equations would be different. Capiche?
The normal equation is different. They have different gradients. Like,
Yeah, but they have the same point equation. You're meant to write it in terms of P and Q, so in bracket. Oh, Q. So you just change all the P's to Q's. Okay, that's fine.
Okay, cool. Yeah, so the real reason is because I want to do some lovely proof by induction. And we have 2 proof by induction questions here.
Can I go to the bathroom?
Yeah, I need to get my water bottle from Mr. Hill. Yeah.
Yeah, no. Let's start with the... Shall we do the division one first?
No. Yeah. Let's just try it. Basis.
Okay, so start with...
Okay, let us do it on our own first.
No, are you mad? Let him do it for
Just
me.
so I can see I can do it.
We don't have enough time.
Good.
Give us like 5 minutes.
We're not gonna prove my induction in 5 minutes. Relax.
No, let's just get it done. So,
You want to do it? Do it. That's fine. I'll pause it. I'll stop the video there and I'll upload what we have and then I'll do a second video just for the proof by inductions. Dun, dun, dun. See you soon.